Hello everyone, this is our project. First of all, we choose Omni wheels because Omni wheels can go to all directions in the XY axis. It doesn't need to turn or do anything to go in any direction. The Omni choice is made because with Omni we don't need gyro because it doesn't like turn a little bit or rotate in any direction. And also the Omni wheels can go, when it's going in this direction, this roller helps us go in the direction and doesn't create any friction. This is our RGB sensor, this is our main RGB. It reads the color and tells us when to drop the boxes. And this is our second RGB. This doesn't read any colors, but in the test run we had a problem reading the colors because of the lighting. So the second RGB is only connected to ground and VCC, so it lights through LED and makes lighting very well. The RGB is at the bottom because it needs to read the colors, which is at the bottom also. And the main RGB's cables go into the upper part of the robot. These two are ultrasonic sensors. These tell us when to stop and when to start the motors. When this ultrasonic sensor reads a certain data, the motors stop and the RGB starts. And also these two ultrasonic sensors are perpendicular to each other. So when, if this is reading data and going in this direction, and it stops, like the last data came, and this direction begins. This one closes and this one opens and this one starts to read because it's reading data in this direction. And this is how it works.
This is our box strapping mechanism. We use rack and pinion. We have a step motor here and a step motor controller here. When the step motor turns, we put the boxes into these holders, and when the robot stops according to the data from the ultrasonics, the RGB sensor read data, and if the data matches our selected color, our step motor starts to turn, and when the box comes here, it drops automatically as this. We have 4 buttons here. The last 3 is the colors. We selected our color cables according to the buttons. This is our red button, this is our green button, and this is our blue button. And the first one is the start button. When we choose a color, according to the color we choose, one LED lights up in the game, and this indicates our selected color. Also, we have an interrupt button. When we press this button, all the mechanisms stop. We have 3 Arduinos. This is the first Arduino. The first Arduino is only connected to the motors. This is our second Arduino, which is connected to the 2 ultrasonic sensors and also to the RGB sensor which is in the bottom. And this is our last Arduino, which is only connected to the step motor driver. This is our second Arduino, and this Arduino is connected to the RGB sensor, which is at the bottom. It continuously reads data from the RGB, and if the selected color is at the bottom, it gives high voltage to the Arduino at the bottom. It also has it is also connected to 2 ultrasonic sensors, and it gives high or low according to the data from the ultrasonic sensors to the first Arduino, which is at the bottom and controls the motors. The first Arduino doesn't stop the motors according to the data from the ultrasonic sensor, and when the robot is the location what we want, the ultrasonic sensor connected to the second Arduino gives high to the motor Arduino at the bottom, and the Arduino at the bottom stops the motors and checks the colors at the bottom. When the motors stop, the first Arduino checks the voltage that is sent by the second Arduino, which is about the RGB sensor. If it's high, the first Arduino sends high voltage to the third Arduino, and the third Arduino, if it gets high voltage, which means the selected color is true, it turns the step motor.
These three LEDs are in between our two Arduinos and checks if the sent data is true or not. This first two, yellow and the blue one, is for the ultrasonic sensors. We can check if the ultrasonic sensor reads the distance correct or not. If the LED shuts down, it means that it should stop, and it should stop in the location that we don't want. It means that the sensor reads the wrong value. The second one is same for the other direction, and the third one, this red one, is connected to the RGB, and we can see if it blinks, the RGB reads the selected color. And we use these three LEDs as a debugging tool.
This is the bottom part of our robot. Here is the first Arduino, and then we have a mini breadboard here. We have two L29 motor drivers. We connect them to the first Arduino, and since we have four wheels, we need to use two L29 motor drivers, and here we have two DC voltage supplies. We use 12 volts to supply our motors. In order to supply voltage to our Arduinos, we used these 9-volt batteries. Here you can see.
One of our regrets is not using an encoder. We thought we could use the PWM and make the robot go straight, but we couldn't do that because with the change of our batteries, the PWM should change, and we didn't have a feedback mechanism. Also, our second regret is in the location of the box dropping mechanism. We drop our boxes from here, but our RGB sensor is here, down here. They're in opposite sides, and in an error, the box dropping mechanism works when the RGB sensor reads a color that it shouldn't read, and if it's in a wrong location at the pad, we drop wrong boxes to wrong places.